There exists a berry that endures temperatures as low as -40 degrees Celsius. It originates from a shrub so robust that it was deliberately cultivated across North America to combat soil erosion and revitalize landscapes where no other vegetation could take root. This particular fruit boasts an impressive vitamin C content, carrying up to 400 milligrams per 100 grams, which is 7 times the amount found in strawberries. Yet, ironically, agricultural authorities and invasive species councils have now identified it as a potential threat, deeming it possibly invasive. They issue advisories against planting it near natural ecosystems, warning of its tendency to form dense, impassable thickets. Consequently, they have established specific protocols to manage its proliferation. For decades, nurseries marketed this plant as the definitive answer to challenging, barren terrains. Conservation organizations championed its use for creating windbreaks and for soil stabilization projects. Now, several of these very same organizations have classified it among plants of concern. Its scientific designation is Hippophae rhamnoides. The commonly known name is sea buckthorn. The name Hippophae, derived from ancient Greek, translates to shiny horse. Legend has it that horses fed the leaves of this plant not only gained weight, but also developed lustrous coats. Regardless of whether this tale is myth or historical observation, sea buckthorn has been historically linked to both animal and human well-being for centuries. Throughout Eurasia, from the European coastlines to the mountainous regions of Central Asia, this plant has been a valuable source of food and medicine. It was not considered a mere curiosity. It was fundamental to traditional diets and practices. Ancient systems utilized its berries for nourishment, its oils for therapeutic purposes, and the plant itself for land restoration. For hundreds of years, people recognized the unique gifts this shrub provided. In the early 20th century, North America began importing sea buckthorn. The initial documented introduction occurred in 1923. The rationale was straightforward. The continent required plants capable of surviving in environments where others faltered. Sea buckthorn met every criterion. It was exceptionally cold-hardy, tolerant of drought, resistant to salt, and capable of fixing nitrogen. It was consequently planted for erosion control, to establish shelter belts, and for land reclamation initiatives. It was hailed as a miraculous shrub, and it performed precisely as expected. Sea buckthorn is a deciduous shrub, occasionally maturing into a small tree. It is characterized by its narrow, silvery green leaves and lengthy thorns. The berries, a vibrant orange hue, grow in dense clusters along the branches and remain on the plant throughout the winter. The species is dioecious, meaning it has separate male and female plants. Both are necessary to produce fruit. The male plants produce pollen, while the female plants bear the berries. In an orchard setting, approximately 1 male plant is typically planted for every 6 to 12 female plants. The shrub propagates through root suckers, allowing a single plant to expand and form a thicket. This suckering ability is the very reason for its effectiveness in soil stabilization. It is also the characteristic that leads some to now classify it as invasive. Let us delve into what elevates sea buckthorn from a mere ornamental shrub to an ancestral survival technology. Firstly, nitrogen fixation. Sea buckthorn engages in a symbiotic relationship with a bacterium named Frankia. This bacterium resides within nodules on the plant's roots, extracting nitrogen from the atmosphere and converting it into a usable form for the plant. This remarkable process means sea buckthorn requires no nitrogen fertilizer. It generates its own. Even more beneficial, it enriches the surrounding soil, providing advantages to other plant species. This explains its extensive use in land reclamation efforts. By planting sea buckthorn on degraded land, the process of ecological restoration is initiated. Secondly, cold hardiness. Sea buckthorn can withstand temperatures plummeting to -40 degrees Celsius or even -43 degrees Celsius, depending on the specific variety. Most fruit crops cannot tolerate such extreme cold. Apples, peaches, and cherries all have their temperature limitations. Sea buckthorn, in contrast, seems to revel in winter. Thirdly, salt tolerance. Sea buckthorn thrives in coastal regions, along roadsides treated with de-icing salts, and in saline soils, environments where most agricultural crops would perish. Fourthly, drought tolerance. Once established, sea buckthorn requires minimal water. Its deep root system allows it to endure dry summers that would decimate conventional orchard crops. Fifthly, it flourishes on marginal land. It grows in poor soils, on rocky slopes, and on sandy dunes, locations unsuitable for cultivating wheat, corn, or soybeans. Sea buckthorn shows indifference to such conditions. It establishes itself, it spreads, and it produces. The very traits that render it a climate-resilient ancestral crop, its suckering habit, its tendency to thicken, and its ability to thrive on impoverished soils, are the same attributes that result in its classification as invasive. When a plant succeeds without external assistance, when it expands beyond designated boundaries, when it does not remain confined to the area where it was planted, the system labels it problematic. Now, let us examine the contents of these berries, as this is where the narrative of suppression begins to falter. Sea buckthorn berries contain approximately 400 milligrams of vitamin C per 100 grams. To put this into perspective, strawberries offer only 59 milligrams per 100 grams, and raw tomatoes provide 14 milligrams per 100 grams. Even when processed into juice, the loss of vitamin C is relatively minor, around 5 to 11% of the total ascorbic acid. Juice concentrate production results in greater losses, approximately 50%. However, even in this concentrated form, the remaining vitamin C content remains competitive with the most well-known sources. But vitamin C is merely the beginning. Sea buckthorn produces two distinct types of oil. The seed oil is rich in linoleic acid, an omega-6 fatty acid, and alpha-linolenic acid, an omega-3 fatty acid. Studies on Canadian-grown cultivars indicate that linoleic acid constitutes 33 to 36%, and alpha-linolenic acid comprises 30 to 36% of the total fatty acids in the seed oil. This omega-3 content is a rarity in berries. Most berries are primarily composed of sugars and anthocyanins. The pulp oil exhibits even more unusual characteristics. It contains substantial amounts of palmitoleic acid, an omega-7 fatty acid. Research reports indicate that palmitoleic acid makes up 32 to 42% of the pulp oil. Omega-7 is uncommon within the plant kingdom, being primarily found in macadamia nuts and certain fish. Sea buckthorn, however, produces it in significant quantities. The seed oil and pulp oil possess entirely different fatty acid profiles. The seed oil is rich in omega-3 and omega-6, while the pulp oil is characterized by omega-7. This implies that sea buckthorn is not a singular functional food. It is effectively two, depending on which part is extracted. The oil content itself is noteworthy. Seeds can contain up to 12.5% oil by weight, while pulp is reported to contain 8 to 12% oil. For a berry, this is extraordinary. Most fruits are predominantly water and carbohydrates. Sea buckthorn, conversely, is an amalgamation of oil and vitamin C encased in a tart skin. The plant dynamically adjusts its chemical composition in response to its environment. A berry cultivated on a coastal dune will exhibit differences from one grown on a mountainside. Yet the fundamental nutritional structure remains consistent: high vitamin C content, elevated oil levels, and the presence of rare fatty acids. This leads to a crucial question that illuminates the entire situation. If this shrub is remarkably cold-hardy, drought-tolerant, salt-resistant, a nitrogen fixer, and yields berries with exceptional nutritional value, why is it present on invasive species watch lists and conspicuously absent from grocery store shelves? The answer is twofold. One aspect is biological, and the other is economic. Both factors present disqualifications within a system that prioritizes control and ease of handling. Firstly, the biological challenge. Sea buckthorn performs precisely the function for which it was intended. It colonizes harsh environments. It propagates through root suckers and establishes dense thickets in nutrient-poor ecosystems, such as sand dunes. It can outcompete native vegetation, encroaching upon prairies and riparian zones and displacing other species. The Canadian Coalition for Invasive Plant Regulation lists sea buckthorn among notable invasive plants. Flora of North America describes it as potentially invasive. Oregon State University's Landscape Resources warns that it has become a concern in the British Isles and on the Canadian prairies due to its tendency to form thickets that shade out competing plants. This represents institutional inconsistency. The same plant once promoted for erosion control is now designated a species of concern in certain contexts. The very traits that made it valuable, its aggressive growth, its suckering capability, its tolerance for poor soils, are the same traits that render it a potential threat in inappropriate locations. It is not that the initial scientific assessments were flawed. Rather, the plant simply fulfilled its purpose too effectively. When a plant surpasses the established boundaries, when it expands beyond the confines of a shelter belt or a reclamation project, the system reclassifies it. Secondly, the economic impediment. Agricultural extension agencies in Manitoba estimate that harvesting sea buckthorn necessitates approximately 600 hours of labor per acre. This is in stark contrast to mechanized grain harvesting, which can be accomplished in a fraction of that time. The berries grow tightly against thorny branches, are delicate and easily damaged. Hand picking is a slow, arduous, and labor-intensive process. While mechanical harvesting attempts have yielded limited success, some growers freeze branches to loosen berries, while others cut entire branches for processing. Every method involves trade-offs. Fruit quality can suffer, labor costs escalate significantly, and while yields are reported to be respectable, around 4 to 5 metric tons per hectare, approximately 1.8 to 2.2 tons per acre, yield becomes irrelevant if the crop cannot be harvested economically. Furthermore, orchard management presents its own complexities. Given that sea buckthorn is dioecious, meticulous management of male and female plant ratios is essential. Extension guidelines recommend 1 male plant for every 6 female plants, or about 7 to 12% of the planting dedicated to pollinators. Deviating from this ratio can adversely affect fruit set. Pruning is also challenging due to the plant's thorns. The modern food system is not designed for crops like sea buckthorn. It is geared towards uniformity, mechanization, and ease of processing. Sea buckthorn demands manual labor, precise timing, and a tolerance for thorns, none of which align with the industrial agricultural model. Consequently, rather than becoming a staple crop, sea buckthorn has been relegated to niche markets, recognized as a specialty crop and a functional food ingredient. It is sold as frozen berries, juice, concentrate, and oil, and appears in cosmetic and supplement formulations, but it has never achieved widespread agricultural adoption. Despite these challenges, sea buckthorn continues to thrive in the Great Plains and prairie regions. It remains a valued component of shelter belts and conservation plantings. Extension materials from North Dakota describe it as hardy and well-suited for windbreaks and erosion control. It is approved for conservation use and is deliberately planted in Canada. Manitoba and other provinces have developed specialized crop profiles for sea buckthorn, recognizing it as a functional food with commercial potential and providing growers with production guidelines, pest management strategies, and market information. The accumulated knowledge has not vanished, it has simply adapted. Small-scale growers and foragers gather sea buckthorn where it has naturally propagated. Frozen berries are available at farmers markets, and juice and syrup are produced in small batches. Seed and pulp oils are pressed for specialty markets. The plant persists in doing what it has always done. It grows where other plants struggle. It produces vital nutrients in climates that most crops cannot tolerate, and it endures. If you are contemplating cultivating sea buckthorn, it is imperative to understand the surrounding context. This is not a plant that can be simply placed in the ground and forgotten. Always consult local invasive species guidelines first. In certain regions, particularly near sensitive dune systems, wetlands, or native prairies, planting sea buckthorn is actively discouraged due to the tangible risk of thicket formation and competition with indigenous species. If you intend to cultivate it in a controlled environment, such as an orchard, a hedge, or a managed landscape, the risks are reduced, but you will still need to manage root suckers and prevent its spread beyond your designated area. For those interested in consuming sea buckthorn, the most accessible entry point is frozen berries. They are excellent in smoothies. Their taste is tart, almost astringent, but their exceptional vitamin C content is undeniable. Juice is another option, although processing does lead to some reduction in vitamin C. It is crucial to differentiate between seed oil and pulp oil, as they possess distinct fatty acid profiles and serve different purposes. Seed oil is rich in omega-3 and omega-6, while pulp oil contains omega-7. When purchasing oil, be informed about which type you are acquiring and the reason for its specific composition. Sea buckthorn occupies a complex and often contradictory space. It is deemed too challenging for industrial agriculture, too aggressive for certain conservation objectives, and yet too beneficial to be entirely disregarded. It is a plant that the modern system struggles to categorize. As a result, it persists, planted in some locales, cautioned against in others, harvested by those willing to exert the necessary effort, and overlooked by those who are not. They introduced it. It succeeded. Now, it is under scrutiny. Not because it failed, but because it flourished beyond the confines of the framework they established for it. Every individual who learns that the thorny shrub lining the roadside offers more vitamin C than strawberries becomes a voice harder to ignore. Every forager who harvests those vibrant orange berries during a -40-degree winter serves as living proof that resilience, unconstrained by permission, still exists.